Hi, everyone. I'm very excited to open this hour, which is going to be a presentation of the various projects that came out of our hackathon, our innovation challenge, which was run in parallel with this conference. So we, as a group, came up with what we hope it was an innovative structure in that we wanted to avoid the usual pitfalls of most of these kinds of innovation challenges or competitions, in that usually you have 24 hours, people coding, trying to come up with some slick demo or UI, and that has limited utility and impact. So for this one, we really asked people to contribute ideas and teams, and it was a co-opetition in that the participants were asked to not compete in order to just win a single prize, but rather they were challenged to cooperate, compete over the best ideas, and then cooperatively implement them. So in an era where interoperability and the complexity of the technology is becoming increasingly apparent, instead of having small groups duplicating efforts to come up with the same idea and really having a lot of waste, we encourage people to bring skill sets and the best ideas so that they could then figure out how each of their various disciplines or their expertise could then fit as a building block of something that could have broader impact and more interoperability. So I'll let Clement, who helped manage and guide the innovation challenge, talk a little bit about the process and how that actually happened in practice. And we also had 5 judges, just really world-class judges from around the world, evaluate and finally select a winner out of the 3 winning ideas. So, and Andrew will talk a little bit about what the judging criteria was and how that, and who the winner eventually was.
Okay. I'll try like this. So basically what she was explaining to you is that we just try to change the way that the operation model during this kind of competition happens. And the way we did it was to apply something that we've been working on for some time about how do you implement technology usually that don't cooperate with each other in a smooth way. Some of the technology that are being applied at some point, and you will see with some of the presentation among the energy sector, are bringing what we call exponential technology, and we've been working with people like David Arban and the Network Society into bringing this kind of technology in a decentralized way and how it could be applied for political, social, economical, and whatever you can think of. So one of these technology that changed very rapidly over the last decades or so is the synthetic biology. And so you're probably familiar, but now you can sequence a human genome for almost a few thousand, when before it was for a few billion, and it took 10 years to do it. So at some point, the MIT and people at Stanford joined together and they started the iGEM competition, which pretty much bring students into doing biological stuff that were until recently just reserved and accessible to just a few. And the concept of the competition was that each student that come and play a part into the challenge would document the project. They would be noted on the project itself as a biological agent, but also in terms of documentation, in terms of collaboration. And so every year since 2003, we moved from 3 teams to 300 almost teams with people who are just reusing the work that was being done the previous years. So it's pretty much like a brick Lego system. And so what's interesting is that if you take this kind of concept and you bring it into the blockchain technology, and tomorrow we'll see some people who are working on, like, for example, IoT, what become interesting is that you have all this kind of technology who are coming online easier, biological, neuroscience, drones, and everything. And when you think about how do you implement this kind of decentralized system into them, there is some interesting things coming out of it. So from the blockchain ecosystem, what's really cool is that you have a lot of projects, you have a lot of expertise, you have people who are working on smart contract, people who are working on identification system, others in cryptocurrency. And so when you look at the landscape of the project, you have a lot of people, a lot of competence, a lot of group, a lot of way of financing their project, but it's very hard for them to collaborate with each other. And so because of this, a lot of these projects in any kind of innovation system have to restart from scratch, either from the financing, either from the protocol they are using, or the documentation, or just the project they are going to be launching. So what we are looking at is just an experiment, but for the last 2 days with the teams was to try to implement the iGEM model into the blockchain community. And so the idea was to bring a lot of cool people that we've been lucky to work with around the table and to see what are their skills, what are the projects they are working on, who are the people in the community who are doing in something similar who could be compatible with them. And to do that, as Primera was saying, is we try to change the way the hackathon is moving, because in regular system, and especially when you do sponsorship, you have a bunch of kids who come for 2 or 3 days. They get free pizza, and pretty much we ask them to start from scratch and find something that's going to change the world, and that's just bullshit. It doesn't work. But sorry. But it does something which you can't just do with computer, which is create trust. People are becoming to know each other, and in the long run, they start to work together, but probably not in the project that was emphasized. So we've been trying to do this, and the approach, as she was sharing, was about collaborative and also documentation. And we did also some work on both, because we are very lazy, and we were lucky for the people at Koala to organize this trip. So basically, we just do something very simple, which is we use a collaborative hackpad, which pretty much help you to have teams working together on the same document. And what we asked to the team that will be presenting their work was very simple. Can you just identify the topic you want to research? What are the people who are going to contribute in your project? So this competition won't be just with one team getting one prize and working on that project, but it will be multiple teams in the blockchain community collaborating with each other into trying to solve things that all of them are trying to solve on their own. Then we ask them also to know what are the needs that they have, and what we will be trying to do now with the community is what are the bricks that the people who are working on their own project can contribute and bring into this kind of dynamic. And finally, what will be interesting is that we have a lot of organizations, like among in this room, we have universities, companies, startups, makerspace, who are all quite often having a difficulty to collaborate with each other. And we believe that because of the thing that you've been hearing for the last day or so, about collaboration, technology that kind of empower people to have smoother and probably a more incentivized system to be able to work together, it will be feasible to have this kind of methodology being applied for this. And finally, thank you for the 3 ladies who organized everything. And now I think we will have what, the judge or the team presenting? Team presenting.
Hi everyone. I'm just waiting for my mic to turn on. They tell me it'll turn on in a second. Great. So I worked together with Greg, Henning, a whole bunch of people at the Innovation Show. We just like talked amongst each other for a very long time about a lot of topics. And I was working on initially kind of identity / access control policy system, and then we kind of put it together with some other components in order to make a system that, like, with one system replaces ICANN, DNS, and certificate authorities for the internet. So I'm just going to like describe it to you. So we're going to use blockchains to maintain a replicated state of a domain registry. But instead of registering domains to IP addresses, we register domains to credentials, kind of smart credentials that have recovery and revocation built into them, so that you can deal with compromise. Like one of the big problems with like identity theft and credential theft in general is that you can't easily revoke it. Like you lose the credit card and then someone uses it, and that's why it's really important to call them up quickly so that they shut it down. Same thing with the passport, etc. So the cryptographic credentials, instead of just being like a public key, also has revocation and recovery policies associated with it. So we have a mapping from names to credentials, and then the credentials are used to sign DNS registries, like IP addresses, and there's a whole bunch of other things that can be in DNS registries. So ICANN manages the registration of names, and one of their main responsibilities is to prevent domain squatting and resolve disputes. And to do that in a decentralized way, we use this reputation system called Backfeed that Primavera is working on with Matan Field and some other people. And it's a Sybil-resistant public reputation system, so that you can kind of have like a decentralized way to police domain name squatting. So basically, the system works like you pay a fee to register a name, and then if other people don't challenge you, then you get to have that name, and then the name is associated with credentials, which you can lose and recover, and you use those credentials to sign DNS registries. And then a user follows your domain name to your credential to your IP address, and so you can change your IP address without changing your credential. If you lose your credential, you could recover it yourself without a centralized identity provider. You can like have custom recovery and revocation policies that suit whatever trust configuration that you have. If you want to use an identity provider, you can. If you want to use keys that you have in your safe, you can. But you can kind of use these policies to maintain control of your identity. So the domain name is mapped to like credentials that are easy to use, but also you can recover, which are mapped to the DNS registries. So we don't actually need certificate authorities at all in the system, because the certificate authority attests to the fact that someone with this domain at this IP address has this has this cryptographic credential. But by mapping the name directly to the credential, we just eliminate the need for certificate authorities at all. And so certificate authorities, the federated DNS system, and ICANN actually are like the main centralized points of failure of the internet. And they're the reason why it's like so easy to get man-in-the-middle attacked. So with this kind of like fully decentralized system, I think we can make some progress towards making HTTPS actually secure, and some progress to having less like cybersecurity problems in the world at large. So I'd like to thank everyone who helped, ask good questions, and so on. And I hope you like my idea. And if you have any questions, just yell it out or I'll repeat it. Yeah, so he asked, one of the things that came up is to look at this being the kind of access policy thing as a way of controlling access to contracts themselves. So if you're going to access a contract via some kind of credential, it'd be really cool that if you lost that credential, you could revoke it so other people couldn't access the contract using it, and then you could recover it so you can regain control. So in general, for any kind of like control of a resource, it's smart to have a credential with a revocation and recovery policy. Hey, V.
Another interesting use case, access policy for legal contracts.
Yeah, access policy for legal contracts, sure.
You'd actually be able to get a document where you can cryptographically verify at least that it is legally binding for some particular corporation.
Sure. So Vitalik said that another useful application would be for access policies for legal contracts, and I agreed. So then the last something I haven't mentioned yet is like if multiple people register for a domain name, so first when one person registers, there's gonna be like some period of time, like 2 weeks, when other people can also register, and they all pay a fee, and then the distributed reputation system will be used to like select one of them to be the person who like should have that domain, as kind of like a decentralized anti-domain name squatting system. Because there is no way to do that just with an economic mechanism alone, because you can't tell from people's bids who really should have the name. But you can like take everyone's money and then pick one of them. Yeah. Sure. One last question.
Yeah, I was just wondering, like, give an actual example of the user experience flow, like how it's.
Oh, you go to google.com, page pops up. Yeah.
I mean, registration.
Oh, I mean, you go to like GoDaddy, and you go and you say what domain you want, and you give them your credit card information, and then and then instead of you just assigning that to an IP address, you would assign it to one of these smart credentials, which would be a triple of your cryptographic key, a recovery policy, and a revocation policy. Sorry, just to repeat the question, it was how would this look like from a user experience point of view of like actually registering a domain? So thanks so much. I hope you enjoyed it, and I hope we can, decentralize the internet.
Collaboration. It was a collaboration with Enigma and Koala and the Absurdist team. And the idea was we wanted to identify how we can merge each other's skills in order to provide a way for providing big data in a way that remains compliant with privacy. So the idea is that people can put their personal data on the system, on a distributed hash table, and they can assign particular conditions. So for instance, they can, certain category of data, they can say that they accept this data to be used for commercial purpose, that other kind of data, they do not want it to be used for commercial purpose, or they can put a price. They can say that this data set can be used only in exchange of a certain amount of remuneration. And so that's on the user side. Now, on the operator side, you have multiple operators that might actually want to do some kind of big data analytics by using this data. And every operator has to provide what is the terms and conditions under which it's going to use the data. So this allows a system that is inspired from the model of Creative Commons, in which right holder can license their work according to specific conditions, which becomes those kind of badges. So there is no derivative, non-commercial, etc. And the idea here is to apply this model, but on personal data set. So on the one hand, the user will have multiple data packages with multiple particular badges and conditions. And then the operator will also be certified according to the extent to which they are willing to respect those conditions. So you can have multiple layers. You can have, for instance, an operator that has like privacy compliance level 1, level 2, level 3, etc. And then the Enigma system can automatically match the certification of the operator with the terms and conditions that the user has decided when releasing the personal data. So to some extent, it's an innovation over the current model of Enigma, in which user needs to assign token individually to all the operators that will have then the right to make queries over those data sets. And in this way, it becomes this kind of public licensing, in which users just don't need to know in advance who will actually use the data, but they just decide what is the level of privacy that they want for the different data set. And on the side of Koala is the legal part, so the analysis of what are the terms of condition of the different operators, and the creation of those badges that are in line with this system. I think that's about it. Is there any questions? Good.
Hello, everybody. Sorry to keep you waiting. I must confess we were totally unprepared for a presentation. Something went wrong, and we didn't know there was a need to present on our idea. I'm Han. I own a company in Singapore called Autonomous, and we came up with the teams in the workshop in the Innovation Center at CBA with what I think is a very interesting use case. If I had 7 lives, I would probably start another business today doing this. But I thought it was great to have input from Ethereum developers, from Primavera and the team on the legal side, from Tata Consultancy on some IoT stuff, and from a number of consultants and people in the room. So essentially, if we get the slides up, which I've just done over the last 5 minutes, I want to introduce you let's keep the suspense, HDMI cable, maybe. I think we want to have some things to talk to. When you need to rely on technology, it goes wrong, right? Now slideshow. Or you take the laptop. Oh, there it is. Introducing the Electron, with the ETH standing for, thank you, ETH standing for Ether. And basically what we were thinking is to use blockchain as a peer-to-peer micropayments and settlement market for a smart grid, electricity grid. Right? We feel that blockchain is the ideal rails to make micropayments, and you could envisage that when you have, for instance, solar panels on your roof, you will use some electricity, but you may send some into the grid. But at the same time, you may also consume. And it would be quite neat to have a sort of daily settlement at the end of, let's say, close of business, where you can actually net your use and get a payment into your account or see a payment leave. Now, there's a little bit more to it. There is a very interesting energy equation, I guess, where we are seeing some fundamental changes. On the production side, we see more and more power being generated decentralized, right? Tesla came out with the battery that you sort of stick to your wallet, to your wall. And the idea is that more and more people start actually installing ways of generating electricity at the end user level. At the same time, there are present mechanisms for carbon offsetting, but they're woefully inadequate, right? I think we all feel their shortcoming. On the production side, on the consumption side, apologies, you see that people are actually starting to insist on a mix, and more choice of providers, but also a mix of the source of their energy. So renewables definitely comes in the picture. And then there is a huge amount of tariff obfuscation, as we call it, which, taking out an electricity contract is a bit like a mobile phone contract 5 years ago. It's very difficult to figure out what you're actually being charged for and what layers your charging is happening. So we feel that there's a real problem here in the existing energy markets, and the problem originates that there is no real way of coping with smart grids as they are being rolled out. And one of the key problems is that there is no payments and settlement protocol that can cope with these continuous micropayments that will result from using the smart grid. And perhaps more fundamentally, there is no way of coloring the provenance of your energy. And so we introduced a sort of watermarking scheme where in the smart contract, you would essentially have 2 colors. You would have a green color and a gray color, depending on where your energy is actually originating from. Now, the key challenge to make all this work, so we like to introduce the Electron as sort of the solution here. So it is effectively blockchain-powered decentralized marketplace where you can basically trade electricity tokens. So it's an asset-backed token in a open decentralized marketplace where there's price discovery happening. And secondly, there is that element of watermarking the provenance of the electricity unit. So the technology essentially, it's an application of a smart contract, right? It is essentially sitting there with 2 things. One is probably your link with the kilowatt per hour, which is the ideal way of expressing electricity because it shows a certain commitment to deliver or take from the grid. So it's not watts, but it's more kilowatt per hour. And then secondly, it has that watermarking with the provenance of the electricity. And I was coming to the key challenge here, and perhaps the weakness in the system, is the verification. You need to have some way of verifying where is your energy actually coming from, right? Now, in sort of the current carbon verification context, this is really quite a centralized and occasionally corrupted way of saying somebody who's planting a forest in Indonesia is getting X amount of carbon credits. You know, we know it's subject to fraud. We know it's not really working. It's an attempt to insert some market discipline, but it doesn't quite work. So I think what we should try to do is come up with a way where we insert IoT, and we had some input there, where your meters at the sensor level can somehow add the origin of your energy. And there should also be something which we call non-algorithmically verified origin, which is to do with reputation. For instance, if you see that McDonald's is switching all its styrofoam cups to easily decomposable cups, you may want to somehow reward McDonald's for doing that, and somehow find a mechanism of rewarding them. So we came up with what we call the Elithron Commons. So the Commons is a concept where you have a sort of a treasury that is being managed by consensus, where we can all decide by applying that consensus algorithm or consensus protocol that we do want to actually reward McDonald's for being more responsible. So it's a mechanism of effectively rewarding people to do the right thing. And the reward would be actually very simple. It would basically allocate some of these Elithrons to McDonald's. So you would get free energy, in other words. The other way of going about it, perhaps complementary with the sort of Elithron Commons, would be that you put some regulatory cap. So some regulation may kick in here where you say to people, look, you can only have an X number of gray Elithrons for you to spend. That is being applied currently in the carbon trading mechanism system. We see it as potentially a way of encouraging transition to a greener way of using energy. So in summary, we see three sort of areas where blockchain could be applied in this context. It would be as the rails underlying the market and the price discovery of these Elithrons. It would be the mechanism to clear and to settle the micropayments in the system. And finally, it would be the ledger to document the provenance of your energy. And that would be renewables versus, carbon burning sources. So that we did this in 28 hours, right? That was the time we were allocated. So thanks to the teams. Thank you very much.
Hello. Hi, everyone. Hi. So it was very intense 26 or 27 hours. Some amazing brains all in one room, which was a real pleasure to see. And it's no surprise that the ideas that these teams ended up remixing and building together in the end were pretty impressive and pretty grand in their scope. So just to summarize, we had fully decentralized internet. That's pretty serious idea. We had the Elithron, basically smarting up the electricity grid and tokenizing electricity. And then we had, the idea of being able to maintain privacy in big data analytics, which is incredibly powerful as well. So what we were looking for, or what the judges were looking for from these ideas, was having a collaborative approach. So, as we all know, the guys who are involved in this, they've all been around the block a few times. They've built some amazing things already. It wasn't about them coming together to hack some code. It was about leveraging each other's expertise and technologies in order to solve a serious, problem, social or environmental problem, or at least, looking at the fundamentals of blockchain technology. The winning idea was also envisaged as something that was likely to have global reach if possible, to make as much of a difference as possible to the world. Some of the other criteria that were looked at were practicality and usability of the idea, because ultimately we do want to see these things getting implemented and being out there in the wild, and also the adoption and impact of the idea. So the judges that we managed to secure for this were a bit of a who's who as well. So we've got Bruce Schneier, very well-respected security expert and cryptography expert from Harvard. Peter Todd, one of the Bitcoin core developers. Alex and Don Tapscott of the Tapscott Group. And Gabriela Leisho, who's a Bitcoin researcher from the Institute of Technology and Society in Rio de Janeiro. So without further ado, the outcomes of the judging were, if I'll go through each of the ideas, so the decentralized internet idea got a total of 18 points. The Elethron got 25.3 points, and the big data idea got 22. So it's my great pleasure to announce that the winner of the Blockchain Innovation Challenge in Sydney 2015 is the Elethron. They're debating as to who should receive a prize because it was a collaborative innovation challenge. Everybody did help.
So it shows he was part of another team and that helped us as well. So they,
Definitely.
So the idea was really like all the ideas were done in collaboration with most of the teams. So there was no like one team and one idea. It was like many ideas and many teams.
but Vlad has some difficulties getting his mind around. This is
He
brilliant. He couldn't understand it. He was a Lego block for a house and Lego block.
So look, we don't have a novelty check to hand over, unfortunately. I'm sorry. But what we do have is a commitment to see this idea built into a prototype over the next 6 months. And the project, as we all know, is made up of not just Han, and it's made up of a lot of different teams. So what we hope to see, as an outcome of this innovation challenge is for this prototype to be built and demoed maybe at one of the next blockchain workshops somewhere else in this wide world. So thanks very much, everyone.
Cheers. Good luck with that. Hey, everyone. So I'm going to grace you with a nice long talk with 1 million slides. If I can find the clicker. There it is. So let's get going before we get behind. So I'm going to talk about the effect of decentralization on society. It's a big topic. Should be fun. So firstly, I'm a researcher at Ethereum. Let's not take any more time with me. I'm going to organize this talk kind of around 4 questions that you might have. And basically, they're not like, what is the effect of decentralization on society? There's, what's going on here? What might we do? What might we actually do with this thing? Should we care? And if so, what can we do about it? So let's go. I would love to have this screen show that, but this screen does. Is there any way to get that to happen? I don't know. I'll just stand over here. So, oh, great. Awesome. Perfect. So what's going on here in this crazy, crazy space? Probably a lot of you are here because you read this article. It's the trust machine. We're creating trust. The blockchain is going to create trust, right? And like that is kind of what's going on here. It's going to make trust by making it hard to abuse. It's trusted because they're hard to control. There's like two sides to this coin. Blockchains are trusted, blockchains are hard to control. Let me just go back. Blockchains are trusted, blockchains are hard to control. It's very important that you realize that you can't only pick one of these. They're both come together, and they're like the reason it creates trust is because it's hard to control. That's exactly how much trust it creates. Is exactly how hard it is to control. So applications running on the blockchain are trusted because the blockchain is trusted, and they're also hard to control for the same reason. But wait, how is it hard to control? Well, usually we have a person with a computer with an application, and we use their application on their computer. And if you just control the person, you can make them do stuff to their computer, and then you can control the application. So you control the person, you control the application. It's easy to control. The blockchain model, instead, applications have a blockchain which has computers which have people. We kind of invert that. So instead of trusting like one host computer, we have like many. And this is like quickly an aside, and we'll come right back and talk about a little bit of trustlessness. In public blockchains, people are like punished if they try to abuse the system, right? So it's specifically that we trust them not to shoot themselves in the foot, because if they were to screw with the application, then they would kind of be hurting themselves, and so it's hard to control because basically, but usually being trustless means that like there is no trust involved because you just verify everything. In this kind of context, it means that we're only trusting that people want money and won't choose to lose it. So public blockchains are trustless because they punish bad behavior. I'm sorry, private blockchains. You're really not that much of a trust machine. You don't create that much trust. You aren't that hard to control. You aren't that trusted. I thought you should know that. You aren't trustless either, right? So basically, instead of someone with a computer with an application serving that application to you, we have applications with the blockchain with computers with people. And the blockchain is going to cause these people to be punished if they were to influence their computers in a way to screw with the application. So it's hard to control because any individual people in this blockchain, they can't really screw with it without getting hurt by the blockchain. So in a sense, blockchain applications actually have agency because people in the network don't really control them, because if you were to try to control them, then you would get hurt by the blockchain. The blockchain doesn't like it when you try to screw with an application. So blockchains basically let us deploy secure autonomous applications. And so they're autonomous, they're hard to control, and that's why they're trusted. Just remember that. Don't forget it. So what might people be able to do with this? That's kind of the problem. That's kind of this is the question that will give us a lens into what the possible effect of blockchains on society might be. We can secure the internet. You just heard me talk about this. So yes, we can replace ICANN, DNS, and certificate authorities. What does this mean? What would it mean to secure the internet? Well, for most businesses and individuals, it means we get to have privacy. We get to know that we're not being man-in-the-middle attacked, and that's good because people have like consumer protection things, and businesses have they need to worry about industrial espionage for all sorts of reasons. For law enforcement, though, it means that they're going to have a little bit of a harder time because they can't just man-in-the-middle anyone with like really easily in order to kind of track all their communications. So it makes society harder to control, but it also means that we have less cybersecurity problems. Now, this is a prediction that I feel very strongly about, and this I can say is kind of a strong hypothesis that blockchains will make the internet more secure and will lead to less cybersecurity problems. Probably that also means that society will be harder to control. What does that mean? It's complicated. So the security of private data, it's a consumer protection goal. But we can also do financial applications. You guys kind of know this. And this is all pretty exciting stuff, too. You have trusted financial applications that can't be controlled and who can actually control money directly. So we have this application with autonomy that actually controls funds. It can do what it wants with them because if any one of these computers who are running the application kind of tries to screw with it, they get screwed. So and we can like do title transfers. We can actually clear the title transfers. We can record them, and we can cause title transfers to happen due to triggering of events in smart contracts, or what I'm calling now applications. And we can do a lot of things with financial contracts because the barrier to entry, the cost of deploying these things is actually really small. We can have like custodial arrangements like escrow and things like that. We can have derivatives, lots of derivatives. Any derivative you can imagine that you can program, you can just put it on there, and it'll be autonomous, and then it'll like deliver the payment whenever someone when it expires, or maybe it's like an English option. You can call it any time, that kind of stuff. We can have trusted automated market making. This is pretty cool, right? To have like a market maker that's automated and that you can actually trust, instead of a market maker that's, probably getting the better end of the deal. Put it that way. We can do micropayments and microfinance. So this is actually a pretty exciting thing. There's a lot of things we can do with that. We can have transactions between programs, between things. That's one of the bigger changes. Actually, programs can control funds just by controlling private keys, or they can actually, be these applications on blockchain that not only control funds but also, can be run on untrusted hardware. So all of this stuff is pretty cool. Now, this is pretty scary. We can make anonymous digital currency. It really seems like this is going to be possible. So it's scary. All this stuff is kind of scary, kind of exciting. There's like a lot of possibilities, but there's also things that can happen that, by the same reason that we can produce trust, that are going to be hard to control. And we need to kind of understand that and to like think about what it means to work in this space, to work on this technology, and how can we do that kind of responsibly, right? But so what does all this financial application stuff mean to technology? So mean for society. We can create markets. We can maybe make markets that are guaranteed to be fair, that are auditable and automated. Maybe we can make markets that serve people who are currently excluded or exploited by like existing markets. This is exciting stuff. Like, people really think that this, it's important that we have markets that we can trust and that don't screw us when we participate in them, right? But probably people will also misdesign these contracts, or maybe just design malicious contracts and have markets that are automated, secure, but unfair and illegal. And that's something that we need to be kind of conscious of when we're building this technology, and thinking about what the effect of the technology might be on society. Probably people will be exploited in these markets too, just like they are in existing markets. But at least they'll behave in a predictable way, rather than in a way that's like, discriminatory in a much more case-by-case basis. And maybe machine finance will become a thing. That's pretty out there, but this is something that people play a lot around with, and it's definitely going to happen. So, what does this mean for society? I don't know. We can maybe figure it out. So it's kind of hard to say what's going to happen due to all this stuff. But we can also build governance tools. This is something that people are kind of excited about, especially in the Ethereum community. We can be sure that access to resources are only granted after some due process that like specifically, protects those resources from being like misused. We can make tools that like enforce logic and make sure that the processes actually comply with this kind of prescribed logic. So that could be really useful for making sure that some business process goes according to the rules that the business intends for them. We can create applications for coordinating stakeholders over negotiations. We can give them forums, reputation systems. We can make tools so that people can coordinate over like large groups, even when they don't have like enough trust to say, okay, you run our governance tool on your computer. We create new organizational structures. People are really excited about this too, because we'll be able to have organizational structures that are entirely administered by smart contracts, and organizational structures that maybe have like fewer barriers to entry, of like easier entry and exit of participants. But on the flip side, even though we will be able to like trust that the organizational structures that we encode will be respected, we may not be able to control them, because that's the other side of this coin, right? It's trusted because it's hard to control. So what does this mean for society? Well, we might be able to build governance tools that can help us govern ourselves. And that would be really cool, especially if we're talking about, for networks of people working on the same problem on an international basis, for new organization types. And we can maybe govern ourselves at a lower cost. But it also might make society harder to govern, because we're going to have governance tools used by organizations that we might not like, but we can't stop them from doing that. So, at least it'll be hard. We'll have to do some social engineering, use some traditional police tactics rather than just shutting down their information systems. So now you might be wondering, if I'm predicting your questions correctly, should we care? I probably screwed up. You probably think we should care. Well, yeah. I mean, I think you should care. Probably because it might affect you, but also importantly, there's room for you to help shape the future of this ecosystem. Right? It's still early. These questions are still actually kind of undecided, even though we can kind of see what the nature of the technology is and what kinds of things might be possible. We don't know what kinds of things will actually happen, even though we can see what might be possible to like a certain point. So, if you're a lawyer, you might notice that there's legal challenges here. Probably a lot of them. So you can help. We want to be able to understand this in a legal context. If you're a regulator, you probably know that there's regulatory challenges here. You can probably just feel that from the hard to control part. And so you should totally be interested in this because of that. And we should have conversations and see what it'll take to meet our common goals. Because we're really not trying to be irresponsible here. If you're a banker, there's financial applications, automated market making, and that sounds great, doesn't it? And there's all the derivatives you can dream of. You just like let your quants loose. They'll probably have fun. If you're an investor, you might care. I mean, there's a lot of hype, but more importantly, there's going to be some people who are disintermediated, and so you might want to know actually how this will change the landscape of who is profitable in the future. If you're a technologist, this should give you a pretty big pretty big rush, because it's pretty crazy, and the problems are really exciting and interesting and interdisciplinary, right? If you're an academic, I mean, similarly, right? This has impacts on society. You can study this from so many different points of view. It's interdisciplinary. It is new. You can write papers. You could probably get grants. This is the thing for you. But if you're an individual, everyone is, you might notice that there's some trust that you wish you wouldn't have to rely on. There might be trusted service providers that you would like to have, but that just don't exist. And you might have systems of control that prevent you from doing what you want. So any of these things might make you interested in this kind of technology, right? So you might have things that you trust that you don't want to rely on, things that you would like to trust but that don't exist, or things that are trying to control you that you don't like. Again, because you have two sides of this coin. You can trust it because it's hard to control. You might also be asking, what can we do about it? What can we do about this stuff? I mean, you might think that it's kind of bad. So what can we do to stop it? Well, it's software. It's kind of hard to solve software because people will just copy it, and then they have different servers on different places. People will develop software. So maybe the better question is how can we slow this down? Maybe this is all just too crazy, and we need to slow this down. Well, you can slow adoption. You can slow research and development by regulating the people involved. You could go to the application's users, and you could say, this is illegal. You're not allowed to do that, and persecute the users themselves. You could go to the developers. You could go to the people who deploy the applications. You could go to the people serving the blockchain platform. You could go to the people developing the platform itself. Maybe you can feel that this isn't all too comfortable, but here it gets even more uncomfortable. You can go to the researchers working on the theory and the architecture. And this is where I'm going to ask you to please don't do this. This is me. We can chat. We have good intentions, really. We do. But if you're really concerned that this is bad stuff, like, let's have some conversations. Let's talk about what we can do to be responsible in this space and get some of the benefits without some of the scary stuff about losing control. You can also try to reduce demand for technology. And this is going to be a pretty radical section. By being more trusted. That's going to be tough. Or maybe building confidence. That's a bit easier. You can do that with PR. But you can also just be more trustworthy, right? That's tough. And I'd recommend this to you, to all of you. Really, this is great, especially if you're a lawyer, a regulator, a banker, an academic. We should create trusted institutions that don't exist today, that people are looking to this technology to build, because if we have actually trusted parties, then we have something that we can actually control, but actually provide the service that people want to build. And so you'll reduce demand for the thing that you can't control, but by actually providing the trusted service that is attempting to provide. And here's the most contentious one, by actually repealing systems of control that people are trying to subvert using this technology. Tough one. Everyone just wants control. But if you do this, then the demand and push for this technology will be slowed. But this is, again, scary stuff, right? But I've said it a couple of times. We really, really do want to use this responsibly. Like, I've had like a little moral crisis trying to figure out, can we actually make this good for society? Or is this all just going to get out of control? I think we can do it responsibly. And if you want to do it responsibly, then maybe, and you think it's possible, maybe you want to help. So how can you help? The main thing, the simple thing, is to contribute to educational efforts. Learn about it. Talk to people about it. Produce educational material. But the best thing you can do is actually contribute to research and development by, just investigating, finding use cases, doing research, and sharing it with your peers. I'm a little bad at that part. Funding research, this is important, because you might not be able to do research, but you might be able to fund people who can do research, and that helps a lot. Play with the technology, right? Actually use it. That helps everyone figure out where the kind of rough points are. And the important thing is that if you want to help us do this well, we need to have conversations about kind of the ethics and consequences of building kind of blockchain technology, decentralized technology. So we need your help thinking about the blockchain in the context of society, right? Like, we are at society. You guys are closer to society than we are. I'm just kind of sitting at my computer in front of my computer all day, but you guys probably talk to people. We need your help, right? We need to understand how this plays into existing stuff, because we're pretty oblivious to the stuff that's out there. And we need your help to build healthy norms, right? We need to know, should we be talking to people about how we're going to decentralize them, or should we talk about how they could be more trusted first? And working together, I really believe that we can kind of help shape the future of this technology to be something that's actually quite good for the world and quite good for everyone involved. I think that kind of the collaborative spirit of this conference, can kind of help us understand each other's needs, understand each other's motivations, and help us shape the future in a way that is kind of ethical and responsible. So let's make it good. And thanks so much for listening to me. And I also want to thank the three wonderful women who put this conference together. Yeah, give them a round of applause. And so if you have any questions, I think we still have some time, right? Oh, no. Okay, great. Yeah, just leave it up. Please, just leave it up. Questions? I know there's got to be questions. Hey, V. Here, you just wait for the microphone.
Which one?
Vitalik. Oh, yeah.
Which one? What's geographically closer by now?
Yeah.
So,
Can you give me an example of an instance where you think that we should not make the trade-off in favor of making things simultaneously more trusted and harder to control?
Yeah, I mean, because trusted in this sense means trusted to comply with a logic that's encoded into them, right? And if we just like encode the wrong logic or logic that isn't appropriate for a certain situation, then things can go quite badly. And you know, there are immoral uses of blockchains. I mean, for example, like extortion. I mean, Bitcoin is like the currency of extortion because you can extort over the internet, and they can send you money, and they can't shut down your bank account. You know, things like this could get worse, and we want to avoid these things. Yeah, the contract is trusted, but it's not a good thing just because it can be trusted to execute according to how it was programmed.
To make this sort of more specific, are any opportunities sort of much lower at the protocol level? So not so much, well, I don't like extortion, so let's just like not write extortion software, but more, let's not write this feature which might have benefits, but which also makes extortion much easier.
Yeah, so actually at the protocol level, it's very hard to make these decisions in a way that only affects the bad stuff, right? I mean, it's hard to provide a platform where people can write applications and say, you know, only applications that fit this framework can work. You know, if you have a blacklist, what you'll do is you'll end up having applications that fit that description that are actually fine. If you have a whitelist, then people won't be able to make applications that don't fit that description. So it's I mean, and certainly from like the point of view of like the elegance of the protocol specification, adding like a massive directory of stuff that behavior that isn't allowed if it's detected by the protocol and having everyone check everything. It's just like really ugly from a protocol point of view. And like, you know, these technical considerations do matter. We can't ignore kind of like the protocol's needs and like people's needs when we like design these things, right? It's super hard to even make say that like to have a contract and say that this contract will only ever be used for good purposes. The same contract could be used for something good and something bad. And so there really isn't any kind of protocol level thing that we can do to just check whether the effect of some contract on society is something we would like. Right? So I definitely am not advocating making core protocol decisions in order to kind of say that only some contracts should be allowed or that some contracts should have special treatment. Yeah, that would be blasphemy for me.
Okay. Suppose that the first major global scale killer app of blockchain technology turned out to be either some extremely large scale evil DAO or potentially ISIS 2.0 or something similar. How would we as a community respond?
I mean, so I mean, that's exactly the conversation we should be having, right? I mean, what kind of response do we know that we have? At the moment, you know, if we really believe that these things are hard to control, then, and we did a good job making the protocol, then we should be able to say, actually, there's not much that we can do. And that's, you know, it's not going to be a very pleasant thing to do. But the main thing that I think is really important is that people are aware of this and aware of these possibilities and kind of talk about it, and like that we establish norms, like, you know, don't do bad things, don't make contracts that are obviously going to be misused. You know, we need like to inspire basically a culture of like, you know, good people doing good things with blockchain technology. Greg?
I kind of wonder about your thoughts on the experiential aspect of relinquishing agency to these contracts, right? I mean, so on the one hand, I mean, I think we all have experience of 15 pages into an automated voice system. Press 1 for, right? And that's what it's going to be like to engage with some of these contracts. Exactly that. You're following a flow, and you have no choice but to engage. And so that's one end of the spectrum, right? And we all know what that feels like, right? At the other end of the spectrum, right, there's all the kind of weird chaotic dynamics that come from algorithmic trading, right? I mean, that has not been particularly successful in a lot of ways, right? Because it's chaotic, and we can't predict it. We have topological transitivity on one side and the halting problem on the other, and we're kind of squeezed in the middle there. So on the one hand, we have this cold logic that we can't escape. On the other hand, we have these weird dynamics that we can't predict, that are going to be weird and surprising. So what does it feel like to relinquish our agency?
So it doesn't feel great to relinquish our agency, but it does feel good to deploy an agent that helps us. So, you know, I certainly don't want to be listening to, you know, options on a smart contract and then having an inconvenient user experience. And I want to be using tools that are you know, somehow guaranteed to give the right kind of economic efficiency properties or market efficiency or whatever the goal is. But I definitely understand that it's hard to predict what programs will do, especially when they're interacting with each other. And so, you know, this is exactly the kind of stuff that we need to build norms around, that we need to have conversations about, so that the things that, and then the reason that it's really important and that we can actually affect change by having these conversations is that the things that are adopted will form network effects. I mean, market mechanisms are a great example of this, right? Like a market maker with few customers is going to be less successful and will attract fewer customers than one with more. So by creating network effects around good applications and attracting use cases to those, we can kind of help shape the outcome. And I think the way that we can do that is by kind of exploring the space of what could go wrong from the point of view of user experience, from the point of view of just like computer science, like, you know, can we predict what this contract will do? And yeah, I mean, it's difficult to predict the effect of blockchains on society. The only thing I'm really kind of confident in is that it'll help us secure the internet. But you know, I'm also optimistic, and I know that most of the people who are working in this space have some particular application in mind where people could benefit a lot from the provision of trust in a circumstance where now trust is being abused. And I think that it's really important, actually. You know, there's a reason The Economist suggested that the technology behind Bitcoin can change the world, is because, you know, there are lots of trust problems in the world, and there's lots of cases where trust is abused, and where removing the possibility for trust to be abused can improve people's lives in like a direct and meaningful way. So you know, even though I might have been a little bit bleak at times, I'm actually quite optimistic about our ability to make this turn out well. It's just going to take thought, responsibility, having conversations with people who know their context, and seeing how that fits in context with blockchain. So you know, there's no reason to be too afraid. Just have fun, and let's hang out and build cool stuff together, right?
Hello? Yep. So you can look at blockchain as potentially being an enabler for the next wave of globalization. And that's one of the really exciting things about the whole week of events that happened this week, because it's got a view as to how we can effectively regulate blockchain technologies and the exchange of value across borders, where, you know, there's obviously a lot of legal complexity and so on. And that's, if we can overcome those sort of hurdles, then, you know, in terms of societal impact, obviously that can have a really, really big impact in the developing world and so on, connecting people with value and so on. But purely on the societal side, if you take this discussion to its endpoint, then given enough complexity in these smart contracts and given enough time and experience at developing them and optimizing them and testing them and so on, can you see this sort of model, this decentralized model, as potentially being a disruptor to governments in the long term? Given that, you know, we've talked we've definitely talked about the collaborative aspects of the blockchain and governance by design, distributed voting systems and reputation systems and all these sort of things. If you actually follow it to its progression, I could, at least theoretically, envisage this as being a mechanism to organize people on a really grand scale. Do you think that the technology itself is equipped to do that? Putting aside the scalability debate, forget about the scalability debate because
how did you know I was going to bring that up?
We've had enough probably for the day on that. But aside from that, do you think the technology is equipped to do that?
So there's two questions. One of them equipped to enable collaboration and governance on a global, massive scale. I would certainly like to think so. Certainly, it's more equipped to do that if it is possible at all than a service provided on Google servers or Amazon servers or particular government servers. So if there is a way to kind of do global governance, then this kind of protocol that can be trusted by anyone but also can't be corrupted by anyone, because it's a very promising way to do it. Also kind of along those lines, one of the reasons that we kind of fear people coordinating in very large organizations is that if those organizations end up having lots of people rely on them, and therefore they realize that they can kind of extract rents by the fact that people rely on them. But if that organization has business logic encoded in like something really reliable, then it could be like in the code that it will not seek rents after people start relying on it. And I think that could be really powerful for things such as a global governance kind of system. But your other part of your question was whether this could pose challenge to existing governments. And I think that certainly the answer is yes, from the point of view of this is more inconvenient to regulate and control than other systems. Now, it's worth noting that since the kind of punishment that the blockchain enforces on malfeasors is economic, you can control it. There's just a price. There's so much money you need to spend, so much coordination you need to do in order to control a blockchain. And so, any given blockchain today, probably any government, any significantly sized government could, if they had all the right information, pose a very significant threat to that system. So, even though it's inconvenient for them to shut it down, it doesn't mean that it's impossible. It might be that in the future these things become so massive and publicly used that no single government has the funds to undermine it like that. But that's a distant future. So at the moment, it's more like a thorn in the side of governments because it's harder to regulate because you can't just send a court order out. You have to kind of also compensate people for the loss they incur due to the fact that they are running something that they don't know what it is, but you don't like it, right? Because it's important to realize that people who host these applications on a blockchain are not aware of what applications they're providing. They just have a computer online that they make sure is always online to serve these requests. So it's just inconvenient to regulate, and that is definitely a thorn in the side. But certainly, there's no question that large governments can control blockchains today. And I happen to love thinking about attack strategies. So if you're curious, come talk to me. Yeah. There's a question here.
With the widespread adoption of blockchain, do you think there will be fewer lawyers, fewer bankers, fewer accountants, fewer government employees, and fewer programmers?
I doubt there'll be fewer programmers. So basically, it's a kind of a difficult question because I don't know exactly what the job of a lawyer, a banker, et cetera, entails. There's going to be some of it that's automatable and some of it that isn't, right? So there's definitely an extent to which a contract sitting on one of these blockchains it doesn't have access to the world, right? It will need trusted people to provide it inputs to make judgments about things that happen outside of the kind of crypto sphere. So it's certainly not the case that all of the functions of lawyers, bankers, regulators, etc., will be filled by automated applications. But to figure out what part of their responsibilities can be automated and what parts can't, you need to have intimate familiarity with their professions. So, I don't know, that'd be cool to work out, but I can't really tell you.
Yeah, we've got a question here. So these are incredibly complex systems, especially if they're done well, right, in order to make them secure enough. But they hold immense power, right, which means that a very limited number of people are able to envision a system that's both powerful enough and secure enough to use. Do you imagine that that in and of itself is an issue of accessibility for people to architect their own systems? And if so, do you imagine a future where platforms are made easy enough for people to develop and architect their own systems based off of some solid sort of base level definitions?
I mean, yeah, you nailed it. I mean, it's really hard to kind of architect and create a blockchain, but if you have a blockchain as a platform, that platform could make it easy for you to build applications on top of the blockchain. And I mean, that is kind of the goal of the Ethereum project. We want to build like a decentralized platform, scalable one for decentralized applications or for, trusted applications that are hard to control. But not necessarily hard to control in the sense of, if you bake in the rules of the application and say, oh, okay, if these people vote this, then they decide what happens. That'll be easy to control. What's hard is to kind of violate the logic of the application. So yeah, I mean, the idea is to make platforms that people can use easily, rather than to have everyone make the platforms from scratch themselves. There's a question here.
Yeah, so my question's around assuming large corporations, governments, and so on actually want to do things for the right reasons. Is the blockchain technology, private blockchain technology, a significant advance on the way, say, data is stored today, and is it worthwhile for them to set up these private blockchains in order to make whatever they do be more robust and more secure for end users?
So there's certainly an extent to which it is. So I mean, blockchains are like consensus protocols that have like a lot of digital signatures and hashing going on. And so there's like definitely an extent to which it makes it harder for like a hacker to get in and modify data unnoticed. So it definitely does add trust because it makes some things harder to control. But the network administrator can still control it. So there's definitely a value add, but it doesn't create trust on like a kind of societal level, right? Where if I don't trust the bank, then I'm not going to trust their private blockchain, right? If I don't trust the network administrator, I'm not going to trust the blockchain that they operate. But if there is no network administrator, then all of a sudden I can kind of trust the applications that are on there to execute according to the way they're specified.
Sure, but is there enough of a step in doing that today, not in 2 or 3 years' time, to make it worthwhile, in your opinion?
So surely a lot of these institutions have information security properties, and they should be doing anything they can to prevent compromise and breach and modification of their databases. Do I think that like having an internal blockchain will make your bank trusted? No, I think that you need to do like repeatedly treat your customers well in order to build trust.
Thank you.
We've got one over here.
Just a question on the resilience of the blockchain in its current state. If quantum, or when quantum computing becomes a reality, particularly given that it would probably be in the hands of a few?
Sure. So the main thing in like these blockchains that is quantum, prone to like quantum attack is the signature schemes. But there are quantum-resistant signature schemes. They're just kind of sometimes they're one-time use. Sometimes there's much larger. I'm not an expert on quantum. But certainly, quantum-resistant cryptography is like a field of research, and we would have to move to those primitives in that environment. Wait, you have to wait for a microphone, Greg.
Where is it?
Down here. We got a quantum expert on our hands.
Which one?
Right, yeah.
No, quantum computing makes a lot of the things that blockchain is, a lot of the computational complexity that goes into blockchains are obviated by quantum computing. So you don't necessarily need a consensus algorithm of the complexity that we're seeing today if you have certain kinds of transforms that are available to you.
Okay.
Yeah. So that's, it's like.
So I guess then the actual blockchain will need to run on quantum computers.
Yeah. You just.
Yeah. So if we had quantum computers for everyone, then we can make more efficient blockchains.
You just don't need them. You don't need them in the same way.
We'll see. So I guess that's all. Thanks so much for giving me extra time, Primavera, and thanks for all your time. Oh, do we have another? Oh. Sorry, we have another question.
No, not really.
No, we don't. Great. Let's drop away.